All right, zero power. We talked about the zero power rule yesterday. All bases raised to a power of 0 are equal to 1. Doesn't matter what the base is. So, for example, x to the 0th power. Again, it is a base raised to the 0th power. It's going to equal 1. Multiplication. All powers raised to another power equal that base raised to the product of the exponents. So this is our power to power rule. Notice we have a power inside the parentheses getting raised to a power outside the parentheses. When we see a power getting raised to another power, we can multiply those two powers together. Now, the reason why this is the case is because we have a to the m a certain quantity of times. So however many that quantity is, we could then say a to the m times a to the m times a to the m, whatever that quantity is. Now, our rule today will give us a better understanding of why we can multiply those together. Negative exponents. Negative exponents in the numerator get moved to the denominator and become positive exponents. Negative exponents in the denominator get moved to the numerator and become positive exponents. So remember, we talked about wanting to get along with your brother, and when your brother is super annoying to you, the easiest way to get along with him is to send him downstairs to the basement. When he's downstairs in the basement and you're upstairs relaxing, you're happy, he's happy, everybody's positive. Now, the same is true that on Friday night when you want to watch your movie, if your brother is downstairs annoying you, you send your brother upstairs. If your brother is upstairs, you're able to watch your movie. He's happy, you're happy, everybody's positive. Function notation and root notation. Now, function notation is beneficial for us to understand. You're not going to see it a whole lot in this unit, but you are going to see applications of it as you move through algebra. And so it's beneficial for you to understand that x getting raised to the mnth power is equal to n root of x to the mth power. Now, the most common example of this is x to the 1/2 power. Now, notice, if my top term is m and my bottom term in the fraction exponent is n, we are basically saying the square root of x to the 1st power. Well, x to the 1st power is simply x, and the square root doesn't need the operation sign. Doesn't need the number here for us to know that it's square root. So x to the 1/2 power is the same thing as saying the square root of x. Well, that's interesting. So 8 to the 1/3 power. Notice my third bottom term is going to come here in the radicand space. My 8 is going to go in the box, and we would be to the 1st power. Now, these are super fun problems here because eventually you will learn that 8 is 2 to the 3rd power. And so we are taking the third root of 2 to the 3rd power. And when we take the third root of 2 to the 3rd power, notice what happens to these numbers when I put them back in fraction notation. We end up with 2 to the 3/3 power. Well, what is 3/3? That's 1. So we end up simply with 2 as a solution. Now, I just showed you how you could go in the reverse order, which is basically what our next statement is saying. The nth root of x to the mth power is equal to x to the mnth power. Again, you're not going to see a whole lot of these in the 7-8 program, but those of you that can grasp this concept and hang on to it for next year are going to be ahead of the game. So our example, the third root of x to the 6th power. Notice my n is going to be under my m, with a base of x. Well, what is a 6 divided by 3? That's simply 2, so we simplify down to x squared. Multiply two exponents with the same base, you keep the base and you add the powers. So a to the nth power times a to the mth power becomes a to the n plus m. These are probably the most common rules that you will end up using, is the product rule and the quotient rule. So a couple of examples. A to the fourth power times a to the negative third power simply becomes a to the 4 plus negative third power, which equals a to the first power. We don't need that 1 anymore, so we simply say a. Now, some of y'all are probably thinking, Mr. Gable, that was a negative attitude right there. Yeah, it is. You're exactly right. And so we could certainly take the a to the fourth, put it in the numerator, bring the a to the third downstairs to make him happy, and then try to simplify. Well, let's notice we have 4 a's in the numerator. We have 3 a's in the denominator, and I can cancel out 1 for 1 until we finally are left with 1a. There's going to be lots of different ways to simplify exponents, and so I will be checking your work to see if you're using the rules correctly, but you have lots of flexibility in which rules you use when. All right, a to the fourth times a to the b value. We have a to the 4 plus b. Now, not a whole lot I can do with this one at this point in time because we have 2 variables. I don't know the value of either. So we simply leave it as a to the 4 plus b. A to the 5th times a to the 3rd. So again, we'll have a to the 5 plus 3, which is a to the 8th power. To divide 2 exponents with the same base, you keep the base and subtract the powers. This is similar to reducing fractions. When you subtract the powers, put the answer in the numerator or denominator depending on where the higher power was located. So this is a lot like adding and subtracting integers. Remember that when you had 3 plus negative 4, we find the difference between the two, which is 1, and we keep the sign of the larger absolute value number, which is 4. So we keep its sign. This kind of works in a similar way. So depending on where we have the higher power located, that's where we will keep the base with whatever remaining exponential value we have. Now, I say that, but I don't really care if you put your solution in the numerator. As long as you follow our no-no rules, you cannot have a negative solution for an exponent. So I'll show you what that means as we get to an example. A to the nth over a to the m is equal to a to the n minus m. So an example, a to the 5th. Now, we already saw an example of one that was just like this, where a to the 5th over a to the 4th gave us a times a times a times a times a with 4 a's in the denominator. And so we could cancel out 1 of each until we were finally left with a. Now, once we start using the quotient rule, we realize a to the 5 minus 4 allows us to simplify this a lot faster, and we end up with a to the 1. And notice I leave it in the numerator because my 5th power was higher in the numerator. A to the 5th over a to the 3rd. Well, a to the c, We can't really combine 5 and c. They're not like terms, but we can still apply our quotient rule and say a to the 5 minus c. The power in the numerator minus the power in the denominator, because both have the same base. To simplify an exponential expression where the base is a fraction, multiply the power to term's power in the numerator and each term's power in the denominator. So x divided by y raised to the 6th power is simply going to become x to the 6th over y to the 6th, which we can get rid of the parentheses and then say x to the 6th, y to the 6th. All right, let's apply the fraction rule. Now you'll notice that now that we're applying the fraction rule, we have a couple of other rules taking place too. So first thing I'm going to do is break my fraction up. I'm going to take this term, 2a to the 3rd over b to the negative 1 to the 3rd. And now we realize, hey, I've got powers to powers taking place here. So 2 to the 1st power raised to the 3rd gives me 2 to the 3rd power. A to the 1st power raised to the 3rd gives me a to the 3rd power. On top of b to the negative 1 raised to the 3rd gives me b to the negative 3rd power. Now I can see that brother's not happy down here. He's got a negative power. And so in order to make his power happy, I'm going to bring it upstairs with the rest of the family. So we have 2 to the 3rd, a to the 3rd, b to the 3rd. And the last thing I want to do is clean this up because it's small enough that we can simplify it. 2 to the 3rd is same as 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. A to the 3rd, b to the 3rd. And we simplify it as far as we can.